Hello all. Today's topic is regarding container monitor. So in the recent trend, what we are seeing with respect to the software defined vehicle is the containers will be one of the key essential parts in the SDV vehicle. So the predominant space where it actually happens is where there will be an app store kind of a thing, where there might be multiple applications which a user wants to be deployed into his vehicle, like a play store, or if he wants to do any update of the existing applications, that also will be mostly container based only. So with this being said, and even if you refer my previous videos, you can see some of the videos where I have extensively discussed regarding OTA based containers and the other applications of containers in the vehicle perspective. So coming back to the topic, when the containers are so essential in the SDV ecosystem, basically what will happen is there is a possibility which the OEMs have to consider, that there might be some rogue containers from third party applications which will have malicious content which might overload the entire system as such, which might compromise the entire vehicle. So for that to be avoided, I have previously spoken about a lot of container based restrictions and kind of scrutiny which has to be done from the OEM side before it is deployed into the vehicle. And one of the specific methodologies, I will anyways add that particular video in the description, is with respect to restrictions of the resources from C groups. So what it means is, say when a container is basically spawned, the host machine, which is basically the car, can restrict the amount of CPU, memory, PIDs, and other consumptions which the containers take. That can be restricted. By doing so, say there is any malicious application also which it is trying to use more resources, it will be restricted. So this is the whole idea behind this particular C groups based resource restriction. Now when that happens, basically what happens is, once in a while, say there is a particular application and the application is supposed to run within one CPU, and say for some reason the application inside the particular container, the actual container is trying to consume 2 or more CPU cores. So anyways, the vehicle as such, the OS will restrict it within 1 core or so, but once in a while some spikes do happen, and we really don't know whether this particular spike has created any issue or not in the vehicle. So it is always necessary to basically log all the resources which are being consumed by this particular application. Means, what I mean to say is, you have been allocated one CPU core and say you are consuming the entire one CPU core. It means that you are consuming 100% of what is being allocated to you. Say out of the one CPU core you consume only 0.5 CPU core, it means that only 50% has been used by you. And same, if at all there are some occasional spikes, so like occasionally for a fraction of a second, if it goes to 2 CPU cores or maybe 1.5 CPU cores, we need to see all these particular spikes or the resource consumption of how much of the actual allowed limit is being crossed. Okay. Now this will be this needs to be monitored across various parameters, not just CPU, like memory, PID, the IO, data rate, etc. Now when this is being done, basically we actually need a tool to monitor all these particular resource consumptions. So as we are speaking with respect to an embedded system, and that to an automotive system, the preferred programming language of that particular monitoring tool should be either C or C++, ideally speaking, where it does directly the calls to the kernel where it gets the resources. Another major point is with respect to having a very small binary size, so that this particular monitoring tool, because irrespective of the how many containers are running, this particular tool should run throughout the life cycle of the particular vehicle, from the drive up, means from the vehicle start to the vehicle stop. So when that happens, the binary size and the resource consumption of this particular application should be as small as possible, and the rate at which the data has to be sampled should be very high and should be flexible also, because we are speaking about SLB applications, SLA applications, and QM applications to be in form of containers. So few applications need very high sampling rate, few are okay, but having a higher sampling rate is beneficial for us. Apart from this, it would be really great if at all we have a live UI, so that while doing a bench test, we can try to figure out if there are something, we can try to create some test cases and we can figure out where the issues are. And this particular tool, whichever we are trying to build, should not be tightly coupled to a specific container runtime, like this tool works only with Docker, or this tool works only with Podman, or it works only with Elixir or something like that. It should be independent of the container runtime, whichever it is. And it should even be able to export the data, so that if at all we want to do a post analysis of the issue, we should be having that particular capability. So these are some of the ideal features of the tool which has to be there. Okay. Now getting into the existing list of existing tools, there are quite some existing tools available. So let us go with the most popular one, which is Grafana or Prometheus. These are like the tools which are built specifically for this purpose. But the problem with this particular tool is this is like it consumes a lot of resources, and it is built for pure cloud applications where resource is not a constraint. So you can have the best database, you can have the best UIs, and you can have everything, so that you can basically get the best amount of data. So though it is really good, but from the footprint with respect to the amount of resources it consumes, that too in an embedded system, Grafana and Prometheus cannot run in a car. Even if you want to make it run, it will run, but it will consume a lot of resources. So that is the issue with respect to Grafana and Prometheus. Same goes even with cAdvisor also. It's a tool from Google. Though it is not as heavy as Grafana or Prometheus, but this falls under that category only, and that this is basically written in Go. That is another issue. When we come to the inbuilt the mechanisms provided by the container runtime itself, like Docker stats or Podman stats, the problem over here is the refresh rate is somewhere around 1 second. You cannot customize it, and on top of it, it doesn't save all these particular logs so that you can do post analysis. That is another issue. Same goes even with cMonitor. cMonitor is something which is written in C only, but it doesn't have a live UI. You cannot modify the sampling rate, and it has its own restrictions also, because it is not a multi-threaded system, it's a single threaded system. So say you have say maybe some 40 containers running in a vehicle, then it will be very tough for you to serially go to each and every container, get the data and kind of save it. So that is another issue with respect to cMonitor. So while I was researching regarding those tools, these were the tools which I found out, and from there basically I thought that okay, fine, like there is a gap in the market, and maybe I can just create a concept, or I just wanted to try out and create a new tool, especially for this particular requirement which you have with respect to the SDV ecosystem. So this is where I created this particular project. It is called as Container Monitor. It is under MIT license, so anyone can basically freely use it, so that's not an issue. And this is a project which is written in C++. Let me go back over here. So this is a project which is written in C++. The release binary size is 300 KB, so it is literally nothing. And the memory consumption of this particular application is almost zero. Even if you run 40 containers in parallel, then basically the total amount of CPU which it might consume is maybe some mine is a 4-core machine, so it consumes somewhere around 5% of the CPU, 4 to 5% of the CPU max. And the sampling rate is flexible. We can go down as much as 20 millisecond per sample, but we can go even further, but I have not tested it that thoroughly. And I did create an optional live UI for debugging purpose. Whether you want, if you want to have it, you can just enable the flag and you will have a live UI, else it will be a simple logger and it will be logging in the background, and once the application stops, it exports everything into a CSV. So that is the idea. And it is independent of the runtime, because it directly accesses the folders in the C group, so that you can directly get the details from there. So as of now, I built it for Docker with C group version 1, but it can be scaled to Podman also, and it can support C group version 2 as well for now. And for post analysis, I export everything into a DB as well as into a CSV file, so that post analysis can be done. And I created some UI dashboards for our own analysis. And this is the first release which I have done for this project, which is the release is 0.1.0. So by looking at the release ID, it is quite clear that it is just a concept, and it has to go a very long way for maturing in a proper shape. So yeah, so this is regarding the project. In the next video, I will create a demo video of this particular application, so that you can basically have a look with respect to how this particular application works. And yeah, you will try to get more, you'll get more insights when the live demo is up. Thanks a lot for your time.